do science. So Alan Grimm, doing primary job is senior data scientist at a small startup based in Mali, moving San Francisco called Sovolve. And my secondary job on the side is cloudability, half-time data science work, demoing time series prediction. So I have pretty much no life, but I had time to make this presentation, so yay. All right, so the goals. Crash course on infinite theory in the most basic form that we need for this moment. Stack Overflow's subset of statistics stuff is cross-validated, and so I decided to pull data from there because they get their data for free on their website somewhere. So I decided to pull their post data to use in this demo because it seems fitting. And then a few sample models pulled from this data to explain what a model is from one perspective, and then an application of a model. So, starting with a basic coin flip. You have a biased coin, you have a not biased coin. The unbiased coin, you flip it half the time as it's heads, half the time as it's tails. If you flip it, you don't know ahead of time what's going to happen with any certainty at all. The biased coins say you're going to get 80% of the time tails, 20% time heads. Before you flip it, you're pretty sure it's going to be tails, and so you have some information ahead of time. More of the story and the theme I will repeat in a second is that the even chance among all options says the most entropy and least information. A biased distribution means you have more information and less unknown, less entropy. And so information and entropy are interchangeably. I won't use many more words beyond that, but entropy is a word I'll use a lot in this presentation. All right, so some guy in, I think, the 50s, Shannon, I forget the date itself, it's a long time ago, the founder of information theory, as we claim him to be, thought of a formula to describe information. This is the only form I'm going to give you the entire time, so you can gloss over it and it's OK. More of the story is he needed a few properties, the most important of which is the central point of evenly distributed data should give maximal entropy, and as you start biasing data, you should give less entropy and more information. And so based on one variable, this is the equation. Here's some distributions. The entropy at an even probability of 0.5 is 0.5, and you go off the side and you see the curve yourself. That's the hardest slide I have this whole talk. Moving on. Slightly easier slide. Last slide was based on one side at a time. This is the magical curve you'll see in any of the theory course you ever take. The idea is in the center you have maximum entropy, which is even probability of both sides, half chance of heads, half chance of tails. As you go onto one side of either side of the coin, say 80% heads, you're going to get an entropy of the whole system of that 0.722, which is less entropy than the half chance, which in words, as I already said once, even the distribution means you don't know what's going on with any certainty, and the more biased you get, the more certain you are of what's going to happen. Are we good? I tend to talk fast, and I have to talk fast in 5 minutes. Great. All right, so coin flip. Here's the numbers. Entropy 1.0 for heads and tails even. Lower entropy for biased coin flip. Uniform probability means maximal entropy, et cetera, et cetera, et cetera. Moving on. The data we use. Cross-validated posts. 68,000 posts and change, 5 variables each. These variables sort of processed, but know each post has a score, has a favorite count, has an answer count, has a comment. We're all tech guys. I assume you all use this site. If not, check it out. Moving on. So a model, it's a subset of variables, which could be the whole set of variables. That is the table of conditional probabilities. Each variant of data science has its own definition model, but this is only used for today. And so if you only look at the models, the score and favorites variables, and you compile all your data, the probability of having a score of less than 0 and a favorite count of 0 is this. And so a different example is in this other model, the SA model, the score and answers model, where you aggregate all your variables into subsets of that. The probability of having an answer count greater than 0 and a score of 0 is that much of your data. And so here is the same chart as the coin flip heads and tails, but in a slightly more complex data. And this is the other hardest slide I have in the presentation. We're good? Okay, good. All right, so compare these two models. You run the same calculations before, but on more variables, entropy, higher, lower. Lower means this is more biased, which means ahead of time, if you say you have a favorite count of 0, but you want to figure out what score it's going to be before you actually know it, you have a better chance of getting it because this has less entropy, so you know it's happening ahead of time more. Some more information, less information, same size table. So we're picking model for prediction. Okay, sorry, get ahead of myself. Moving on. Other challenge we face is model different sizes. Not all variables have the same number of states it can take. And so comparing two different tables, this table has more entropy, but also has more possible values. The two notions that apply in many models that happen is the, oh, 5 minutes really? Oh, it's terrible. Okay. So all this.
Can you wrap quickly?
Yes, wrap quickly. As I alluded to earlier, a model is useful because if you plot the conditional probabilities in a matrix, and you say ahead of time you have the S, the score, and you want to guess what the body length is, it works as a predictor as well. For example, if you guess score of 0, the highest probability among all these rows is the middle. And so if you start with a score of 0 and you want to guess the body length, the probability here is highest here, so you're going to guess that the body length is going to be between 50 and 130 characters. If you see a score of over 0, you're going to guess that your body length is in the longest bin. I think that's all I have. Yes. I ran some numbers in a simulator I'm writing. Here's some other useful resources. I'll post these on my Twitter account later if you want to see the slides. Talk to me later if you want to hear more information. And I talked really fast.
Wow, that was awesome. Questions?
Your questions?
Is this the data science that I'm seeing a lot in a lot of the East Coast schools?
And could you repeat the question too?
All right, so the question is this the data science you see in a lot of other schools?
It's coming up in courses I see a lot more.
Yes.
Looking at different ways to analyze the same data.
So the general, talking to a few people about data science and what it is in general, and the consensus among people I'm talking to is there's a lot of sales pitch, a lot of hype, and it's starting to wear off. So trying to find some core content if you just look at data science is really hard. And so schools like that, and schools across the world, are trying to establish a base curriculum that says this is what data science is. The general idea of it is we have math, we have programming, finally the two are starting to meet enough to use all these old techniques from the 60s and from the 70s in ways that actually matter and predict behavior and do work on the data. Yeah, that's a great example of it. It's like economics as an example. So schools, we all have our own perspective of what data science is. I avoided that pitch and tried to teach you a small example because I didn't want to be another guy voice in the crowd saying, here's my perspective of data science. And so we all have our own perspective.
Sorry, was that predictive of like what a user would do in a social network?
Yeah, so that was predictive of what a user would do in a social network. And yeah. Stack Overflow is technically a social network of a sort, and that was a predictor. I did bias the bin sizes to make it look more interesting, though. Yeah, awesome. Other questions? Do I go to Vegas? Not yet, not yet. I need to practice this. I use computers to do my math. I need to get in my head before I go to Vegas. I have a laptop next to me playing cards. Anybody else? Awesome.
Awesome. One more.
One more.
Are you the guy talking about the fine print on those commercials?
If data science ever fails me, I will do that job instead. Awesome. Thank you.
Awesome. Thank you.